Unit 6, Section 6, kites. This is our last type of parallelogram. We did parallelograms last type of quadrilateral. We talked about parallelograms. We talked about a specific type of parallelogram called a rectangle, another one called a rhombus, another one called a square. Then we talked about trapezoids, which is also a type of quadrilateral. It's just not a parallelogram because opposite sides aren't parallel. Oh, sometimes one set is, but it's not a parallelogram. Now we're going to talk about kites. Kites are not any of those. They're their own thing. You know what a kite is. You've probably flown one before, and it is kite-shaped. A kite is a quadrilateral with the following properties. Exactly two pairs of consecutive congruent sides. Consecutive means in a row. Congruent means the same, so you can see them marked here and here. That's consecutive, and then here and here. That's consecutive. Two pairs. One pair of opposite angles are congruent. Okay. And the diagonals are perpendicular. We got the little box in here. And the ones that are congruent for this kite is going to be this one and that one. Actually, it's not those. If you look right at them, it's going to be the wings out here, this way, that way. Okay, those are going to be congruent pieces, just like that. It's usually going to be those wingy ones. So let's look at these kites below and answer questions about them. All right, this one's about angles. Let's see, we have to find the measure of angle B and D. Well, what we do know is that B and D are the same. What we don't know is what they are. So that's going to be X. This is also going to be X. So we have 2X. We also have an 85. We also have a 43. And if you remember back to the very beginning of quadrilaterals, we looked at polygons in general and the rule for the interior angle measures. And that's how many triangles you can form. Well, we can draw that little diagonal right down here. And that's two triangles. One triangle is 180, two triangles is 360. So the total inside of a quadrilateral should be 360 degrees. So we should have 2x plus, let's see, 85 plus 53 equals 128 equals 360. 360 minus 128 is 232 divided by 2, 116. So 116 degrees. And we're going to use that a lot. Let's check out number 2. Well, what I do know, based on the way it's shaped, because this one's that one and this one's that one, 82 is going to go right here. That's 71, so 360 minus 82 minus 82 minus 71 is 125 degrees. So measure of angle J, 82 degrees. And when we do 360 minus 82 minus 82 minus 71, that's whatever we said, 125 degrees. Look, I even showed my work. Even though I could do it in the calculator, I showed it so that you can see what it is that I did and remember how we got it. All right. Number 3. What we do know is that this is the same as this, and this is the same as that. And if that's 37, because that's an isosceles triangle now, we know that that's 37. And we could figure out Q because 180 minus 37 minus, that's plus, minus 37. That's 106. So P to T to Q, well, what did it say about their diagonals? Diagonals are perpendicular. Oh, that's easy. So that's 90. Cool. So P to T to Q, 90, perpendicular. PQT, well, what do we know about diagonals? Well, we could figure that out. We don't know anything about it particularly, but we do know that a triangle is 180, and we got one that's 37, we got one that's 90. So that's got to be 53 What's 106 minus 53? Oh, okay, so that splits. It splits those. So the non-congruent angles are bisected by their diagonal. They're not congruent to each other, but they get bisected and cut in half. So that's going to be 53 degrees. And QRT is also 37 degrees. All right, give it a pause. Try number 4, see what you can come up with. Here we go. We just learned that bisect, so we know that's 59 degrees. We know that this is 90 degrees. And so we just have to figure out that last piece. 180 minus 59 minus 90 is 31. All right, this was 180 minus 90 minus 37. This is 180 minus 90 minus 59, which was, what did we figure out? 53, right? And 31 this time, so 31 degrees. That makes that 31 degrees. So G to D to E is 59 twice. 2 50s is 100, 2 9s is 18, so that's 118 degrees. DEH was 31 degrees, and DGH was also 31 degrees. All right, number 5, we got a lot more that we need to figure out here. I know that this one's 90. I know that this one's 52. 52 degrees. 3 is 90 degrees. 5 and 6 are equal. So if we figure out 5, we'll know 6. And we know that that one's 90. So if we take and we do 90 minus 52, we get 38 degrees. 5 is 38 degrees. So 6 is 38 degrees because that's an isosceles triangle. Now we know 4 because this is also an isosceles triangle, so that's 65 degrees. And 65 plus 38 is 103 for the whole angle. Not that it matters too much. Except that we know that this one's 103. That's not a 3. We know this one's 103. And we know that combined in total this is going to be 104 degrees. So 360 minus 103 minus 103 minus 104 is 50, and those are cut in half, so this is a 25 and this is a 25. We could also figure it out with 180 minus 90 minus 65. Also, those are 25s. Lots of ways to get there. You just have to do it. Go ahead and pause and give number 6 a try, and let's see what you can do with it. Alrighty, here we go. 4 is 90. That one's easy. Oh, makes this 90, which makes it 90 minus 46, which is 44. Ooh, 90 minus 46. So this is 44, which makes this 44. This one's 46, so 46 degrees, 44 degrees, 44 degrees. That one's 73 degrees because they're matching because it's isosceles. And 273s. So 180 minus 73 twice equals 34 divided by 2 is 17. Because 180 minus 73 minus 73 equals 34. That's this one. And divided by 2 gives you the 17. So 6 and 7 are 17 degrees. All right, let's see what we got. The sides. WX is 14. That means this one's 14. WR is 8. Awesome. And we got to find R to Z. Well, that's 90 degrees. So that's A, B, and C. So a squared plus 8 squared equals 14 squared. So a squared plus 64 equals 196, if I remember correctly. 14 squared minus 64. And so a squared equals 132, square root. A equals the square root of 132. Almost 11.5. All we have to do is find A, because A was RZ, so commonly known as RZ. And we got 11.5. All right, give it a pause. Try number 8. Let's see how you do. Here we go. All the way across is 38, which means that's 19, and that's 19. E to D is 41. C to D. So we're going to use this. So we got C. So we got 41 squared plus 19 squared equals C squared. Or C to D squared if you wanted to do it that way. So let's see. 41 squared equals 1681. 1681 plus 19 squared is 361. If I remember. Okay, well, that's not what I wanted, but go away. 361. And so plus 1681. 2042. Right. 2042 equals C squared. Square root. Square root. 2042. 45.2. So C is about 45.2, also known as CD. Boom shakalaka, shakalaka, shakalaka. Let's keep going. More practice. Let's look at 9, then you do 10. We'll look at 11, you do 12. Let's look at 13, you do 14. We'll look at 15, you do 16. And that is the notes for the unit. So here we go. RS is 10, so are you. RU is 9. QS is what we have to find. Well, we can find this little piece right here. So a squared plus 9 squared equals 10 squared. A squared plus 81 equals 100 minus 81. A squared equals 19 square root. A equals, well, it is approximately 4.4, I think. I'm guessing. I know 4 squared is 16. I know 5 squared is 25. 19's a little less than halfway, so 4.4. It's a good guess. Let's see. Square root 19. Dink. Oh, look at that. I'm awesome. 4.4. Two 4.4s means that QS is approximately 8.8. Give it a pause. Try the next one. GF's 15. C to G, 23. You know that's 90. Find C to D. Well, this one's going to be 15, and that's also 90. So that's C squared. So 23 squared plus 15 squared equals, I don't know what that was. CD squared. Doing it as a whole thing this time. So 23 squared, 529 plus 225 equals CD squared. And plus 225. 754 plus CD squared, square root. So CD is approximately 755. 27.5. That's what we're looking for. Cool. Angle stuff. Cool. Solve for x. All we got to do is solve for x. And what we know about those angles is they're congruent, because this and that and this and that, and the angles between the sides that are not congruent are congruent. So we know 13x minus 32 is equal to 7x plus 22. And we algebra. Minus 7x both sides, so 6x minus 32 equals 22. Add 32. 6x equals 54 divided by 6. X equals 9. Solve for x? Yes, I did. Perfect. All right, go ahead and try to find 12. Remember, you're finding angle L, not just x. On your mark, get set, give it a go. Okay, here we go. Well, that kite, this and that, so these are the same. So I'm going to go 8x on the left minus 31 equals 5x plus 23, just so my x's end up on the left. Minus 5x from both sides. 3x minus 31 equals 23. Add 31 to both sides. 3x equals 54. Look at that, popular number today. Well, if 6 does it 9 times, 3 is going to do it. 3 is half of 6, so we got to double the 9, so x has got to be 18. Now, what we have to remember is we're not looking for 18, we're looking for L. So 5 times 18 plus 23. 50 plus 40 is 90 plus 23. So that would be 113 is the measure of angle L. Boom. Make sure you know that's all 1. And that's all 1. That's how she goes. FOMO. Solve for x. Well, that's interesting. But what we do know is this is 109 because that and that and that and that. And we know that those opposite sides are things. We know that all of them in a thing is 360 degrees. So 109 plus 109 plus 5x plus 14 plus 3x plus 8 equals 360. Whew, Lord have mercy. 109 plus, times 2 is fine, plus 14 plus 8, 240 plus 5x and 3x is 8x equals 360 minus 240. 8x equals 120 divided by 8. 120 divided by, that's a 2. Is 15. Did it say solve for x? It did. I found it. There it is. Let's kick it over here. Give it a pause. Give it a try. Angle of STV. So we got to find out that one. Well, since this is isosceles, I know that it's also 9x plus 1. So all I have to do is plug it into that one. I just need to know what x is. Well, the triangle's 180, and I'm going to take the 90 of that right angle out. So I can say 9x plus 1 plus 23x minus 7 equals 90. Mr. Maggart, there's 180 degrees in a triangle. You're right, but I already took out this 90 from the whole triangle. Okay? Plus, out here is 90, and that is an extended angle. And the exterior angle is equal to the non-consecutive, non-adjacent angles addition. So, boosh, in your face. 9x and 23x makes 32x. Minus 6 equals 90. Let's add 6. 32x equals 96. Divide by 32. Divide by 32. X equals 3. Solve for x. Nope. Got to plug it in. 9 times 3 plus 1. 27 plus 1. 28 is the measure of angle STV. Clear. Find the measure of angle FGJ. F to G to J. We need that one right there. Well, we know that this is 90. And if we knew what that top one was, the 2x plus 11, we could figure that out. What we do know is that this is equal to that because they get bisected. So if we do 5x minus 1 equal to 2x plus 11, subtract the 2x, 3x minus 1 equals 11, add 1, 3x equals 12, divided by 3, x equals 4. I don't need x, but I got to plug it in. So 2 times 4 plus 11, 8 plus 11, 19. So 19 and 90 and something. So 19 plus 90 plus x equals 180. So that's 109 plus x equals 180 minus 109. 171, which is the measure of angle FGJ. Boom. Last one. Give it a pause. Give it a try. Let's see how you do. Find the measure of NQP. N to Q to P. We got to find the whole thing. We do know a piece of it. And we actually know that 4x minus 7 is what that one is as well. And we know that one's 90. So we know that 4x minus 7 plus 11x minus 23 equals 90. 15x minus 30 equals 90. Let's add 30. 15x equals 120 divided by 15. X equals 120 divided by 15 is 8. So 4 times 8 minus 7. 32 minus 7 would be 25 is equal to the measure of angle in... Oh, it's not, actually. If we look at that better, that's just this one, which means it's that one, which means the measure of angle in QP equals 50 degrees. Got to double it. That's all she wrote. That is quadrilaterals, folks.